Hi, this video is explaining about how to build the machine learning training and testing models. The first step in building the model, we need to collect large high quality of data to ensure the better performance of model. After that, the trained machine learning model should be generalized for new real time data. That is, once our model is trained by using the large set of training data, then that model should be able to recognize the new unseen data which is going to be passed into the trained model. Frequently the models are overfitted to the training data. So overfitting in the sense algorithm is too closely aligned to original training samples. That means it will give more accuracy for training data, but when we are giving the testing data as input, the accuracy of our testing data will be drastically reduced. The difference between training accuracy and the testing accuracy will be more, but it will not work better for new data. That's what the testing accuracy will be very less when comparing with training samples accuracy. So the data will be splitted to avoid this issue. The most of the models will use 80 percentage of training data and 20 percentage of training data in the collected input data. The training data is used to train the model, and the testing data is acting as a new and unseen data which is using for to assess the model's performance in terms of accuracy, to make that model as generalized model. In machine learning, we are having one of the scikit-learn package, model underscore selection, which is having the class train underscore test underscore split. So this class is splitting our input data into training samples and testing samples. So two kinds of samples are splitted from the given input and output columns. So the here the test size can be mentioned in the form of percentage. So 0.2 means 20 percentage of input data. That is the thing. Here random state will be mentioned, but for selecting the random number of samples, always same number of random samples for testing and training data set. First, what is the definition for machine learning model? The machine learning model is mathematical function which is trained to recognize the certain types of patterns of given input. So here the patterns are learned from the given input. For example, if you are giving the image as data, then this mathematical model will learn this image, edges, color, and the pattern of this inner pattern of this flower. So the from the image, the mathematical model learns the patterns to recognize its shape. And the mathematical model is here the program which is written to instruct the computer to learn by itself. How to train the model? So earlierly we have discussed about the input data will be splitted into splitted into training data and testing data. Suppose if I have 100 samples as input data, then this input data will be divided into uh, training samples training samples and the testing samples. So here the 80 percentage of samples will be training. 80 percentage means 80 number of samples. So 20 percentage means 20 number of samples will be allotted for testing phase. So here the during the learning model is to be trained over a the training data. Here in our example we took 80 number of samples to find the reasons for identifying the patterns from the training samples. The model will learn the relationships between input and output labels from training data set. So whenever we are taking the data set, the data set will have the number of features, and finally we will have the output label. So the label is called output. The remaining features are called input features. So the training model learn the patterns from input, and it will predict the output. It will calculate the output. This calculate output will be compared with the already given label output. In the supervised learning, so this procedure is following. Then in unsupervised learning, which is not needed the labeled data, right? So in unsupervised learning, the last column, this labeled data will not be available. So here only the features will be used, input features x1, x2, x3. So only the features will be used to learn the patterns. Then it will use the similarity distance metrics to make the to decide the output. Here there is the possibility of error during the learning. There is the possibility of error during the learning. So to improve the learning, then we can apply the optimization approach to improve the performance of model during the training. Then once training is over, here the once training is over, our trained model is ready for evaluation, right? So here the diagram represents, this is the input data. So both are combined together is called input data. Then input data is splitted into training data. The training data is 80 percentage of input data, 80 percentage of input data. Testing is 20 percentage of input data. So here our mathematical function, that is the machine learning algorithm, is getting the input from training samples, input from training samples, right? Train samples. Then using this, it is learning the patterns, learning the patterns from training samples, learning the patterns from training samples. Then after training, it will uh, be trained. So it is called the trained model. Trained model. Once a trained model is ready, then we can evaluate this trained model. So here this is the test data given as input. The from the test data, right, the trained model is evaluated. Then which is in this evaluation, it will predict the output. It will predict the output. This output will be compared with the output label which is already available in the given data set. So this is the working principle of ML model. So here this is the process to build a model. So based on this, the model will be evaluated by using the testing data. By using the testing data during the evaluation, right? Model is once your model is predicted predicted prediction means computing the output predicted output by model compared with compared with compared with our output label in the data set. So what we have seen earlier, 20% of data will be given as testing data. So in the 20% of data, for example, you take the features x1, x2, x3. Here we will have the output label. Here we will have the output label. So the data will be available like this, 1 to 20 samples. Here the predicted data the model is predicting the output by using this x features. Then this output is getting from the predicted output. Then this output is compared with the output label. Is it equal or not equal? If it is equal, your accuracy is good. Accuracy is good. Otherwise accuracy is not good. Okay, that is the thing. So this comparison process is called evaluation. So here the evaluation of the models can be done by using the validation data set. Sometimes the data set can be splitted into training data set, validation data set, and testing data set. But mostly the data will be splitted into training data set and testing data set. This testing data set is also called validation data set. So here the models will be evaluated by using the test data set or validation data set. So to determine the performance of model, we can use the metric accuracy r squared score for regression type of problems. For classification problems, we can use accuracy f1 score, confusion matrix, precision, recall, area under ROC curve matrix. Then we can identify the methods for k-fold cross validation. So there is one of the approach available, cross validation. Cross validation. If we want to check our model with k-fold cross validation, then there is different type of cross validation approaches available. We can go with that to improve or test our model. Then we can tune the hyperparameters for improving our model. So finally, we will compare the machine learning model with baseline baseline values. So if everything is good, then we can implement our model into the real-time environment to test our unseen data. For example, this step is indicating that once our model is perfect, then we can make this model means program software. So this software can be converted into exe file. That exe file can be loaded into embedded device. That embedded device can be used in the real time to test the model, to test the real time environment. So this is the procedure to test the model and evaluate the model. So here when you are evaluating, we should know how that performance of model is increasing gradually by using different approaches. Here we can use one of the thing, our learning curve. The learning curve is providing correlation between learners performance. Here the ML model is the learner. Okay, ML model is the learner. So it provides the correlation between learner's performance on a given problem statement and the number of attempts or time required to complete the task. Number of attempts in the sense iterations, right? Number of iterations or time required to complete the task. You look at here, in the x-axis we are taking learning efforts, number of attempts, and here we are giving the performance. So here in the, when you are applying the number of attempts, in the 20 attempts our performance is 50%. 50%. When you are increasing the number of attempts, our performance also gradually increasing. When you are giving 140 attempts, our performance is how very much increasing, near to 90%, near to 90%. So when you are increasing the number of attempts, our performance of the model also is increasing. So this is the correlation between the number of attempts and performance of the learner or model is provided by learning curve. So here, which is represented by using the graph. Then the learning curve shows the changes in the training and validation errors also with respect to the number of training samples. So here there is the possibility of error here, error, then here the number of samples during the training and testing. When you are giving the 100 samples, there is the possibility of error here. Then when you are increasing the 200 number of samples, there is the possibility of decreasing error. When you are increasing into 1000 samples, then there is the possibility of decreasing error like this. So your learning curve is coming like this. Learning curve is coming like this. So your error is decreasing when you are increasing the number of samples. So this is used to know how the error is decreasing when you are increasing the number of samples. So this is the purpose of learning curve. Then there is two terminologies, bias and variance. Bias and variance. The bias is defined as the mistakes or error caused by models simple assumptions in fitting the data, right? The error which is caused by the model when during the training and testing, right? High bias represents the model is unable to capture the training data patterns, unable to capture the patterns of training samples. Okay, so that is the thing. Suppose the model may capture only 50 percentage of patterns from the training samples, so it is unable to capture the 90 percentage or 100 percentage of patterns from the training samples. That is the problem which is leading to underfitting. Then there is another one term, variance. Variance is error caused by the complicated model which is trying to match the training data 100%. Okay, 100 percentage which is matching with the training data patterns, which is learning 100 percentage. So in this situation, the model will have high variance when it is passing over the majority of samples, that leads to overfit. If it is 100 percentage learning the data with less number of samples, then there is the possibility of overfit our model, our mathematical machine learning model overfit with the training data. So when the model complexity is growing, bias reduces while variance increases, or bias is increasing, variance will be decreasing. So both will be possible. So what is the good model? which is the good model? The good model should have minimal variance and minimal bias, but both is nearly impossible. So for that, what we have to do, we have to make adjustment between both variance and bias when we are building the strong model that performs both training and testing data. So we have to make the balance between the training and testing uh, with respect to variance and bias. So here, this is the high variance, high bias. High bias. Here you look at that, the line red, which is indicating the training error. You see, the model unable to learn the patterns of input training data. So, since it is unable to learn the patterns of training samples, which is giving more errors. You look at here, which is giving more error. So, due to that, the testing data also not predicted perfectly. Here also we are getting more error. This is testing data. So for testing samples also we are getting more error. So from this, what you can observe, training accuracy also less, testing accuracy also less. Okay, testing accuracy also less. So that is the problem in bias. Okay, high bias. Then high variance, you look at that third one. Here the training, the model learns 100 percentage of patterns, 100 percentage of patterns, right, learned perfectly. It learns around 100 percentage of patterns, but the number of samples are less, number of samples are less. So when you are having the samples, number of samples less, in that number of less number of samples, if model is learning 100 percentage of patterns, at that time you, the testing error is high, testing error is high, but training error is very less. So if training error is less and testing error is high, then at that time the there is the possibility of overfitting, high variance overfitting. Okay, because it, the training, the model during the training learns around 100 percentage of patterns of less number of samples, training samples. Then better one is training error also close to the testing error. Okay, both are close. That means testing accuracy and training accuracy both will be, test and train accuracy both will be almost close together, almost close together. Okay, almost close, right? So that is called, when model is having training accuracy and testing accuracy close, I mean nearest values, then that model will be called better model. So here, some data is distributed. You look at that, the underfitting means high bias. Underfitting means high bias. High bias means the model unable to learn, unable to learn the patterns from samples. So due to that, there is the possibility of more number of error. You look at this, more number of error. So this is the high bias. The testing, the error in the testing samples also high, training samples also high. The best fit in the sense, there is the less number of error, less error. Okay, less error. Okay, so here you look at that, only two samples are misclassified, all other samples are perfectly classified, right? Then overfitting in the sense, you see, in the overfitting all the samples are perfectly classified. You look at that, this line is perfectly classifying, okay, all the samples during the training, during the training. Okay, so during the training, perfectly classifies. So 100 percentage, which is learning the patterns of input data. 100 percentage learning the patterns of input data. So this is highly overfitted with the training samples. So that is the example of this one. So there is the three things available. One is underfit, best fit, overfit. The for better model, it should follow the best fit approach. Thank you.